Hello everyone, we are in chapter 3. Chapter 3 talks about descriptive measures of sample and population. So this is the outline of the sections of chapter 3 we're going to take a look at. There are 4 sections in chapter 3 and we're going to cover all 4 sections. In this video, we're just going to cover section 3.1. Okay, so we're going to talk about measures of location or measures of center or central tendency of data. In section 3.2 we look at measures of dispersion or separation of data points, measure of variation. In section 3.3 we're going to talk about box plots, which kind of combines the ideas from both of these sections, and also more so of this one, first one. And then finally in section 3.4 we talk about descriptive measures of population. So everything we do in the first 3 sections assumes we're working with a sample, and in section 3.4 we're going to take up the idea and generalize it to the population. So let's take a look at section 3.1 now. I have written some things for you. Again, I'm doing this just so I make sure I cover all the highlighted items that I want to cover. But as you read in it or looking at it, I'll try to talk and work with it at the same time. Okay. Now, let's begin with our first measure of central tendency. Now, the idea of, again, measure of central tendency is that suppose we have a set of numbers. We want to know what the center of our data is. What is, you can think of the center of data as the measure of most typical measure, the measure that is the most common to your data set. Okay, so that's the measure of central tendency. I call it a typical value. Okay, so I'll elaborate more on that as we go through. So we're going to take up 3 measures of central tendency of data. First, we're going to take a look at the mode. Okay, so we're going to define the mode as the most frequent observation in your data set. Okay, so whichever score that occurs the most. So in here I've given you an example of a data. This is the data I'm looking at right here. Okay, so I have some made up data points here. Okay, and we want to know what is the modal value. Now, whichever value that occurs the most in our data array, that's going to be the value of the mode. So for instance, I can see that there is an 11 here and an 11 here. There are 2 11s actually. Now there's a third one. So there are 3 11s in this data set. Okay, and that's the value that I see the most of. Notice there are 2 16s, for example, 1 and 2, but 11 occurs the most with 3 occurrences. So we're going to call 11 as the modal value for this data. Okay, so the mode's going to be 11, and that's all that is. Okay, the most frequent observation. And let's take a look at another data set. Now, one of the drawbacks of the mode, by the way, as a measure of a typical value, is that it may not exist. In the one that we had, the modal value was 11. That means 11 occurs the most. So 11 becomes kind of like a representative of all of these numbers that you see in example 1. Now, in my next example, example 2, you actually see that there are 2 modes in this one. Okay, so how is that possible? Well, if you look at 115, I have 1 occurrence, 2 and 3 occurrences of that score, 115. Now if you look at 160, there's 1, 2 and 3 scores there. So in this case we actually have 2 modes as the most frequent observations. So the modal values are 115 and 160. So this is what we call a bimodal data. Bimodal. The prefix bi, of course, means 2, correct? So that means it's a two-mode data set. And of course, in our next example, we're going to have a case where the mode actually does not exist. So when I made these up, I want to make them up to where you have an example where there's a single mode. The right example one, you have one mode. Then you have bimodal data, and then you actually have one where there is no mode. So, and this indeed becomes a drawback of using mode as a measure of typical value, in that the mode may not exist, and the mode, there may be more than one mode, and in that case the mode is not unique. Those are the two biggest drawbacks of the mode. The mode may not exist, and there may be multiple modes. Okay, now typically the greater the number of modes, it will be more difficult to analyze the data as well. Okay, so that's as far as what we want to talk about the mode. Now, who would use the mode? Of course, I have this near the end of the video as far as comparing, well, which one do I use? Do I use the mode? Do I use the mean? What do I do? Now, one advantage of mode is that you can actually use mode for both qualitative and quantitative data. Whereas in the case, for example, for the mean, the data has to be, the variable has to be quantitative variable. But in case of mode, that's not the case. It could be both qualitative or quantitative data. So I have an example of that. If you look at, for instance, the data in here, we can say that the modal value in here is going to be a C. That means a C occurred the most frequently in that data set. Okay, where if I wanted to find the mean with those letters, it's impossible because those are non-numerical values. Okay, next let's take a look at the median. Now, the median is what we call the middle value in an ordered array. The middle value. So in order for median to be found, the data must be ordered. We have an ordered array of numbers. An array is just a listing. This is a listing of numbers. So all we gotta do is order these numbers from low to high. Now I'm gonna show you these, and of course we do everything by hand, but later on we're actually gonna process this data through Statcrunch. Okay, so luckily Statcrunch will do almost everything that we do in this course, with the exception of very few chapters, like the chapter on probability, chapter 3, and chapter 4, because this is where we are in 3 right now, in chapter 4, and a portion of chapter 5. Okay, but for most parts it's gonna help us, Statcrunch, that is. Definitely with these it can. Okay, now so remember, in order to calculate median by hand, we need to order the data from low to high. So the second roster that I have here in this second run, this is the first one and this is the second one. I went ahead and ordered this data from low to high. Okay, we ordered them from low to high. Now I need to find the middle value. Okay, so how do I find the middle value? Well, if you look at this data, let's see, how many scores are there? There are like 5 here, and there are 5 in here, right? There are 5 here, that's 10, 15, and 20. So let's say the sample size here is actually 20. Now, when there is even number of scores, such as the case here, there is no directly a middle value directly, so this would be the center or the middle of the data. Okay, in the case where the sample size is even, usually what we do is we actually take the average of the two adjacent numbers. So we're going to take the average of 77 and 78, and that's what I have in here. So we're going to say the median score, the middle of the data, if you will, it's 77.5. That's what the median is in this case. Okay. So how do I find the location of the median? We actually have a formula for it. If you do 0.5 times n plus 1, that gives you the location again. That's not the value, this is the location where you can find it. So for instance, in the example I just did, sample size was 20, so the location for this data is 0.5 because median is 50th percentile, so that's why 0.5 is. The sample size was 20, 20 plus 1 is just that, 21 times 0.5. That's like 21 divided by 2, and that's going to be 10.5. Now personally, for the location, I like to put a superscript th here, as in like 4th, 5th, 6th, and so on. So in this case, the median is going to be located in 10.5th location. Well, we don't have 0.5th location. We have 10th location, 11th location, and so on. So to kind of create a 10.5th location, that's why we average the 10th and the 11th observation. Okay, so there's a value of the median. Now, again, median has a number of advantages, and there's really no disadvantage of the median, but other than what you just saw, is that if the data, the number of data points is even, we have to kind of find the halfway between. For most parts, median is actually used quite often, and it's a very reliable measure of central tendency. Okay, and it has some interesting situations we can use median, and I'll mention about that, I think, in the coming page. Okay, remember, again, the idea is for you to please read these. You can pause the video, read them, kind of soak it up, what I have written, or you can just maybe after you're done watching the video, you can review these notes again. Okay, so let's take a look at our next measure of central tendency, which is the arithmetic mean. There are actually quite a few means, and that's what I have here. We have quite a few means or averages in statistic. Some of these I have listed. We have geometric, we have weighted mean, we have harmonic mean, we have trimmed mean, and we have all these kinds of interesting means. Okay, so which one are we talking about? More specifically, we're talking about the arithmetic mean, this one. Right, so I have listed 1, 2, 3, 4 of them, and then arithmetic mean is the fifth one. The fifth one is the one we're talking about. Okay, now the formula for the arithmetic mean, that's when you add up all the scores divided by the sample size, by the total, and that's what this formula does right in here. You add them up divided by the total. Now, usually we use a summation notation for our formulas that are in this form. So using sigma notation, this is how we can actually write this formula. Now remember, there are 2 sigmas in Greek alphabet. Here's one sigma, and that's what sigma is. The other sigma is this one. We'll talk about both of those in chapter 3. This sigma, the second sigma, this one, we will talk about in section 3.4. Okay, which represents the population standard deviation. So now remember how the sigmas work. Usually you work with sigmas near the end of an intermediate algebra class. Okay, and what sigma means, just the mere presence of sigma, is a command to add. Okay, so for example, if I have a sigma in here, you can think of sigma replacing these words, and suppose there's usually a formula in front of it, so like something that like that in front of it, in this case x. So you can just translate the notation, the sigma notation, as the sum of whatever's in front of it. So those three words replace the symbolic representation sigma. Okay. Now for sample mean, keep in mind we use x bar. X bar indicates the sample mean. Okay, so for example, here in my next example, I made up 4 numbers, 10, 15, 16, 7, and we want to find the mean. You add them up, divide by the 12th. So suppose, let's say those are my scores on 4 quizzes. The quizzes are worth 20 points each. I got 10 on the first quiz, 15 on the second, 16 on the third, and 7 on the fourth quiz. So I didn't do so hot on that one. Okay, and my average quiz score is 12. Okay. And let's say in my earlier example, the numbers that I had, these are the exam scores for a class. And here are the scores. Remember, we found the median, the middle value, once we ordered them to be 77.5. So for that same set of scores, we want to find the mean. So we're going to add them up. One by one, we add them up, and the total gets divided by sample size of 20. And the total, 1550 divided by 20 makes it 77.5. Now, for this data set, the median also was 77.5, and this is pure coincidence, okay, that this happened in my case. Realistically, it could happen, so it's not like, is it even possible for mean, median, mode to be equal? Yes, they could, but seldom from real data that happens. But so anyway, I was surprised that this happened. There's nothing wrong with it. It's not like we're going to change them, but when something like this happens, that just tells me that the scores, if I do a histogram of them, they're gonna look symmetric, and we'll look at that when I'm done with this. We're actually gonna go and take a look at, but not now. Once we're done with this section, maybe I'll show you mean, median, mode. How's that? I'll show you mean, median, mode, so we kind of take this one piece at a time. Okay. Let's continue on. Now, what are the advantages and disadvantages of the mean? And by the way, this is the arithmetic mean. This is your everyday average. Okay, so that's all that is. This is equal to the average. Like, you know, like they hear, you may hear that in, well, you know, what was your average on the exam? There you go. And what is the average income? What is the average rent? And so on. That's your everyday average. It is arithmetic mean. Now, the advantage of the average, the arithmetic mean, is that it is unique, and for any quantitative data, you can actually calculate it. Okay? And the biggest drawback of this is going to be, the greatest drawback of the mean is that it is extremely sensitive to extreme values. Okay? So, let's take a look at an example of that extreme sensitivity to very large, very small values. So let's say I have 5 students here at whatever community college you can think of. Okay. And suppose I ask them how much cash you have on you. And these are the 5 scores that I got. One of them said $10, $25, $20, $500, and $30. Okay, now that $500 score kind of stands out, doesn't it? And seldom you expect the students to walk around campus with $500 cash on them. So this could be some kind of anomaly or an exception. Maybe that person that has $500 cash was on his or her way to make some kind of a sizable, notable purchase somewhere. Okay. Perhaps, I don't know, whatever goes for $500. Maybe you want to buy a used laptop. I don't know. Something from a friend. Whatever that the case might be. So, now for this 4 numbers, okay, I have it as, let's find the mode, median, and the mean. Alright, so let's go for it. Remember, mode, the most frequent observation. I have a 10, a 25, a 25, 530. None of those repeat more than once. In order to qualify for mode, the score should repeat at least twice. Okay, so there is no mode in this one. How about the median? Well, to find the median, we have to order this from low to high, correct? And that is what I did here. So I ordered the data from low to high, and now I can see the middle value. See, when the sample size is odd, in this case N5, there will be a middle value, so you don't have to worry about dividing by 2 the two adjacent scores. And there is the median. So based on mode, if you ask me, well, what is a central tendency? What is a typical, how much is typically carried by students? Cash is carried with them at any time? Based on mode, I can't tell you the answer because there is no mode. So I can't tell you. There is a drawback of the mode, right? Now, with median, I'm going to say that I expect the students to have about $25 on them at any given time. Okay. So $25. Now, that's reasonable, right? Yeah, sure, why not? $25, that sounds reasonable. Now, what about the mean, right? Remember, for the mean, I have to add them up divided by the total. Well, if you look at that one student, remember the one that had $500 because he or she was going to make a sizable purchase somewhere? Well, that, if you divide 500 by 5, because there's 5 students, that alone makes it $100 on average. That's how much the students carry on them at any given time. Now, that one would be a very hard sell as opposed to $25. Okay, so there you go. That would be actually the exact average, $115. Now think about yourselves. Some of you may actually carry about that much, but again, the catch here is typical. The average student, a typical student in a community college, doesn't carry $115 on them at any given time. Now, there may be occasions where people do carry that much cash, but again, we're talking at any given time. That's very unlikely. Okay, so this shows you the danger of using the mean when there are extreme values in the data set. Mean, arithmetic mean, is highly sensitive to extreme values, whereas median is not. And you just saw the median here just looks at the middle value. That 500 could be $50,000. Maybe this person was on his way to, or her way to go buy a Tesla, I don't know, or buy an automobile or something. But whatever the case might be, 50,000 make it, I don't know, 500,000, make it 5 million cash. The middle value is still $25, so that's not going to be affected or influenced by extreme values. And we could have extreme values on the low end. Let's say I have a couple of students. How much money do you have on you cash? I don't have any cash. I have $5. I have $5. Next one is $10, and then you get into $20, $30, $40 range. Okay, so notice for the mean, these three are going to really skew the results to the low end, right? So extreme values could affect the average in either direction. Now, let's see. So which of these should we use, right? Now, it really depends on the situation. Let me actually roll this up. I have some good mentions here of some general guidelines. If the data is somewhat skewed, we use median. Well, personally, I always use median, and I'll explain why that is in just a moment. Okay, but one thing interesting about the median is I mentioned about truncated data that may be truncated. By truncated data means you don't have all the data values. Look at my example here. These are data points, right? So here these data represent the survival times. This is for terminally ill patients. Okay, so we have, suppose I have 9 patients suffering from a terminal disease, and I'm tracking these 9 patients. Well, as of this patient, the first patient, lived for 85 days beyond, let's say, initial treatment. Suppose I have a new drug that I administer to these 9 patients, and I'm going to look at how long they live before they pass. Okay, so the first person lasted 85 days on this new drug, new treatment. The second patient passed after 88 days. Third one, fourth one, fifth one, sixth one. Now, the patients number 7, 8, and 9 are still not in. That means they're still alive. Okay, as of 113 days that I was tracking them, they were still alive. But for some reason, let's say I lost contact with these patients, or they just don't want to participate anymore. They severed their contacts with me. So, but I know again, as of 113 days, all 3 were alive. Now, hopefully, even though I lost contact with them, let's say hopefully they're still alive. So they could be going on for a long time. They could be alive for 2 years, 3 years, 4 years, whatever the case might be. But the point is this: see, this ... is for those 3 numbers. So I have a number here that's on hold, another number, and another number on hold, right? So clearly I cannot find the mode. Right, I cannot find the mode because this, as of what it is right now, there is no mode. And what if let's say all 3 of these pass at the same time? Then my mode could be that number. What if 2 of them pass on the same day? So you see, I cannot calculate mode for incomplete data, and I cannot calculate the average, right? In order to calculate the average, I gotta have all the scores. So I can add them up. I can add them up and then divide by the total. So the one thing I can do, however, even though those 3 numbers, let me put question mark, question mark, question mark, as those 3 numbers are still at large, they're outstanding, I can find the median, couldn't I? Remember, for sample size is 9, true? So the median would be the middle value. So I have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. 1, 2, 3, 4. 1, 2, 3, 4. The median will be the 5th score, wouldn't it? The middle value. And I have that. I have 1, 2, 3, 4, 5th value there. So I can say that the median survival time is 109 days on this drug or using this treatment. That's the median score. And that is the attractiveness of the median over the other 2 measures of central tendency. It works really well with truncated data. Now, we're not going to deal with truncated data, so don't worry about it, but I thought this is interesting to let you know. This is not in the book, but I mentioned it to you anyhow. Okay, so let me continue on. And as far as the relationship between these 3 measures of central tendencies, like how are they related, if anything? Do they have anything to do with each other, these numbers, and how do they line up in a distribution? Well, they have nothing to do with each other. That answers that question. There's no correlation or association between the 3 of them. These are 3 independent measures of central tendency, or averages. Now, this is the relationship among them, okay? First, in a symmetric distribution, all 3 scores are the same. Median is the middle value, so right in here, 50% are below and 50% are above that. Okay, that's the characteristic of the median, the middle value in an ordered array. Now the peak of the distribution, by the way, is where the mode is. So there is the modal value. The modal value is somewhere in here, right? Whatever this score might be in this range, that's the mode. And the average would be the same also. Okay, so keep that in mind. For a symmetric distribution, all three measures are equal, so we don't have to say, well, which one should I use? Use any of them, because they're all the same. Now, in a right skewed distribution, for the right skewed distribution that this is, let's see, where's my cursor? For a right skewed distribution, I actually right in here. In a right skewed distribution, you start with the mode. The next value next to that would be the median. Next to that would be the mean. Okay, so this is how they kind of line up. The median lies between mode and the mean. And the reason the mean is so far away from the other two is because sensitivity to extreme values, the tail end of the distribution kind of gravitates mean towards itself. And that's why for skewed distributions you should never use the mean or the median. I'm sorry, or the mode. You do use the median. In a left skewed distribution, the same thing. You never use the mean, you always use the median. Now I mentioned I personally always use the median as a measure of what's an average or typical score, because if you look at it based on what I just said, in a skewed distribution, right left doesn't matter, right? For both of those, you use median. So here I'm supposed to use median. Well, in a symmetric distribution, it doesn't matter which one you use, they're all the same. So you see I've circled median. Therefore, always use median as a measure of typical or center of your data. Now, going forward, we actually are going to stay with the mean, and we're gonna let go of the median and the mode. So we don't want to undermine their importance. It's just our work is more focused towards using the mean. So we're going to carry forward with the mean as a measure of central tendency and what's to come based on the mean. Alright, and what I just said is here also. And I believe this is the end of this lecture. Okay, so the lecture is about 35 minutes, not bad. So please review this, and then all of these paragraphs, if you read them, they have some really good information for you. What I like to do now is I like to go to my math lab, and I'm going to look at Statcrunch. We're going to do that together. Okay, remember, you have an option. You can do things the hard way. The hard way would be doing it by hand, or you can do things the easy way. The easy way would be to do as much as we can with the Statcrunch. And you paid for it, it's gonna pay itself off for you. Might as well get your money's worth. Okay, so I'm gonna go to Statcrunch, and we're gonna rerun this data that we just saw for the exam scores. Okay, I'm talking about which data? This data right down here. Okay, this data right here, 35, 99, and so on. This data, we're gonna analyze it using Statcrunch. Alright, I'll move to my math lab now. Okay, so I'm in my math lab. Now I assume that you all know how to get to my math lab, right? Now, of course, in this case is my lab statistics. So, in order to go to Statcrunch, we can actually do it different ways. How can we do this? I would go to Statcrunch, see right in here, I'm on the left side, Statcrunch, and left click once. And it brings, or it opens the Statcrunch. Now, at this point, you can invoke it in two ways. You can go to Statcrunch website. My experience, sometimes it doesn't let me in. That's just me personally. It'll ask me for, what's your user ID, password, and I forget those from time to time, so I don't use that option. You can try it and see if you can get in. If you do, that's fine. or you can go for data sets from your textbook. Now let me try the Statcrunch website, and I just clicked on it, and there you go. See that oops here? Oops, you have not accessed this page properly. Sign into statcrunch.com. Now remember, I just went from my MATLAB into this and it didn't work. So I guess I can sign into it, right? If I click on that, now it's gonna, let me X this out. There's so much on this one. And now I gotta read through all of this. Anyway, that's why I don't like going it the way I just did. So I'm just gonna go back. Okay, I'm gonna take back what I did, and actually for this one, let me X this out. Alright, so I like to access it using the data sets from my book. Look at this now. When you click on it, it bypasses all of that stuff. It goes directly to Statcrunch. Okay, and this is the image of the textbook that we have, and we're good. So now I already showed you, I guess, in my orientation video a little bit about Statcrunch, but now we're actually going to do things with it. So we're in chapter 3, and if I click on chapter 3 data sets on the left side, I'm just going to click on that. You can actually see all of these exercises are in your book, and they have some kind of data associated with them. You see that? Lots and lots and lots of these, so you don't have to type the numbers in. But the one that I actually did, let me do mine. I went ahead and typed those in Excel. These are the exam scores that I did, and I'm gonna copy those, and then I'm gonna go to Statcrunch, and I'm gonna paste them. Let's see. I'm not sure. Okay, I guess Control V will paste it, so let me try Control V. Okay, Control V seems to work. Now these are the scores that I had. I can rename var1 as, let's say I call it exam. These were exam scores. I'm just going to call it exam. Okay, now we want to find the mean, median, and the mode. That's all we want to do as far as the quantitative measures go. But before we do that, let's actually just to practice, let's do stem and leaf of the exam scores. We do a histogram and we do a dot plot. Okay, the things we did earlier in chapter 2. So here he goes. Here's a histogram of exams. Compute. There. So it looks like exam score is slightly skewed to the left, right? And we do have an outlier here. Someone scored less than 40. That's an outlier. Let's see who was that score. Let me actually see. A score is, it looks like 24. Or which one was 40? Okay, there you go. 35, the very first one I missed. Okay, so that's the outlier. Notice this thing is highlighted in a different color now. All right. So anyway, that's the histogram, and let's do a stem and leaf for the exams. And there it is, my stem and leaf. Again, suggests that this data is somewhat skewed to the left. Remember, what you call it, a stem and leaf is kind of like a histogram on its side, right? So there you have it. Sorry, that doesn't look that impressive, does it? Okay, so let me actually erase this one and redraw it. Okay, there. So the data is skewed to the left. Remember, the low scores are here, the high scores are here. So the stem and leaf supports the skewness of this distribution. All right, and let's see what else I want to do. Let's take a look at, X that out, a dot plot. We talked about dot plots. So here's a dot plot of exams and compute. And there you go. Now you can actually locate a mean and median on your dot plots if you go edit and markers, mean and median. You see that? And let me come up so you can see a little. I'll bring my recording area down. There. So I can mark these, and there are other options if you want, and put compute. And there it is. Okay, so in this case, note, remember mean and median were 77.5. So here it is. Median and mean are the same. So, but look at the dispersion of this data. It's very dispersed, right? The points do not bunch around a central value. Okay, so in other words, I'm looking at them looking like this. Maybe you see that it's not doing this kind of action. If they did this, then that means that data has smaller dispersion, but this isn't the case here. All right, let me X this one out and X out. Okay, let's do mean, median, mode. You ready? So in order to get those numbers, you're gonna go on stat, and I'm not clicking or anything. Remember, I'm just moving the mouse. You see that hand moving? I'm moving it around. So I'm gonna move to stat, and then come down to summary, statistics. Now we're gonna go summary by columns, and the reason is because the numbers are in columns. Okay, and then I'm just gonna go by columns, and the only variable, analysis variable, I have is exam. If you have multiple variables like exam 1, 2, 3, 4, 5, then they will actually show here, and you can do different things with different variables. So I'm just gonna left click once. Now down here you're getting a whole bunch of information. Okay, let me go down. These are all the statistics that are available with this in this app. So let me just click on sample size for now. Okay, remember we want mean, median and mode, right? So to make another selection, you can kind of read, and it's right. Let me see. Well, sorry, because I activated my pen, so I lost the cursor here. Okay, I'm just again gliding over these names, and look what's down here, just below, right here. That disappears. It reads select more than one item, that is, with shift click or control click. So I'm gonna go to mean. Well, actually, hold on, because see, if you just left click on each, you're gonna lose the other variable on this side. So let's go back, left click on N. Now I'm gonna hold on my keyboard, I'm gonna press and hold the control button. Don't let go, and don't press too hard, okay? So just gently press on control button and hold it, and left click once on the mean. Don't let go of the control button, okay? Keep it depressed, and then scroll down until we see, oh, there's median. Left click once. Don't let go of the control button, okay, until I tell you. And then I'm gonna go down, 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 and there you go, mode is in the end. I'm gonna let go of the control button on my keyboard now because I made all my selections, and there you go. Now later we talk about percentiles. See, your percentiles, you can get them here, and that's it. I need those for very easy. Hit compute and check out the display. The output reads the column variable is exam, the sample size is 20, n is sample size. Here's your mean, median and the mode. There is no mode, as we said, and the mean and the median are both the same. Okay, so that's how you compute mean, median, mode in Statcrunch. Very easy to follow. Okay, so with that, we are done with this video. I'm going to stop this one, and we're going to move on to our next section, which is section 3.2. In section 3.2, we're going to look at measures of variation in that section. So let me go back to my note, and we are done with measures of center.